morning, students. In this pandemic period, I hope you are all fine and safe. Now, we are about to begin our 5th semester class. As you know, it's because of this pandemic period we are forced to start online classes, although we know many of you can't attend the classes online. So, all study materials will be sent to the WhatsApp group, and always help your friends who are not available of internet facility. And we should make use of the available technologies, especially as the computer students. Computer students must know about the online facilities at least that is available for us. So try to follow the classes online and also help your friends who doesn't have internet facilities. Now I'm handling the software engineering and testing paper for this semester, and I have uploaded the syllabus and textbook and reference books in the Google Classroom already. I hope you go through the syllabus. Okay, now starting with our first unit, introduction. So now we have an introduction to the software engineering and testing. Computer and computer technologies are being used for several years, and there are much more innovations made so far, and these new technologies help to solve many complex problems. The more powerful the computer is, the more sophisticated programs it can run. So we are also in this pandemic period, we are also making use of such development in technologies. By using such technological developments, we can have online classes today. So there are development in the technologies, and as the technologies are developing, we can also make our task automated. And so the more powerful the computer, it can solve more sophisticated problems. These new innovations and experiences give rise to the discipline of software engineering. So there is a need for software engineering. And so what is software engineering? Software engineering is defined as a process of analyzing the user requirements and designing, building and testing software applications which will satisfy those requirements. So it is not a mere program running. It may be the collection of programs, and it is defined as a process of analyzing the user requirements. So it is important to analyze the user requirements before starting the development phase. So the first stage is analyzing the user requirements. So we have to know about the requisites of the user or customer before going for the development stage. Analyzing the requirements, gathering and analyzing the user requirements, and then we should have a plan and design phase. After getting the problem, after understanding the problem, well, we have to go for the planning phase. That means in every development phase should be planned, well planned, and we should have a design of the whole developmental system. And after that, we start for the developmental stage, that is building. And after that, after having our software fully developed, we go for the testing phase. And testing the software applications. We are testing the software to know whether it fulfills all the needs of the customers. So the software application should satisfy all those requirements that is proposed by the users at the beginning. So it helps you to obtain economically software which is reliable and works efficiently on the real machines. So the software should be economic. So it should be cost effective. That's also important. And software should be reliable. So it should satisfy all the need of the customers, and it should be cost effective, and it should be reliable, trustworthy, and works efficiently on real machines. It should work on the common platforms that is easily available for the customers. So software engineering have evolved over the last 60 to 70 years with contribution from numerous researchers and software professionals. So the engineering phase is developing for about last 60 years, and there is many more contributions from researchers and software professionals. Many more software professionals contributed much on the development of the software engineering field. They developed a lot of programming languages which with much more options. Technology graduated from an art to a craft form where tradesmen shared their knowledge with their apprentices, and the knowledge pool continued to grow. And this, as we said, the software engineering is evolving through many years, and we learned what is a software engineering. So what is software engineering? In the simple sense, it is the essence of all the past experiences and innovations in writing good quality programs in an efficient way that have been systematically organized into a body of language. So, a systematic collection of good program development practices and techniques. Software engineering is a systematic collection of the good development practices. Good development practices always depends on good techniques. It needs a good software development, needs a good platform, it needs a good programming language, and it should be a systematic collection of all these techniques and program development practices. And of course, it makes use of all the past experiences and innovations. We should make use of all the past experiences. That means we should learn from the past mistakes. All these past experiences and a systematic collection of all the good program development practices. It should depend upon a good programming language and the collection of all these things. A good program development practice, techniques, a good programming language, and that languages that we learn from the past experiences will also help in developing a good software. So knowledge forms the foundation of all software engineering process. And most of this knowledge is gained from the past experiences. This learning from the past, using the past experiences, or learning from the past mistakes. That helps to develop a program that is cost effective and should be systematically organized, and all the process should be systematically organized in an efficient way. So the main factors involved in the software engineering process is that First one, the innovations. Innovations means it is the development in the technological field. So software engineering only depends upon a programming language and the platform in which the software may be executed. So the whole development in the technical field, that is a good platform, good hardware and a good software. That means good programming language. The innovations in this field are necessary. So it is the first factor involved in the evolution of software engineering. And the second one is past experiences. As we said, we should learn from the past mistakes. A lot the past experiences, much more will be the quality of the software. Not only in the software engineering field, if we consider any field of development, any field that have a physical appearance, software is not having a physical appearance, and it is difficult to know whether the software is a quality product or not unless we use that software in the real life. We could not know the improvement in the development of the software, or we could not know the software quality without using it, because it has no physical appearance. But for any other field apart from the software engineering, the past experiences helps a lot in making a project in a perfect way. For example, if we are going to have a building and we give a contract for building a house. If the contractor is well experienced, he could make the building in a perfect way, in a perfection that even we may not expect, with much more perfection that we have expected from that contractor. He can do in a perfect way because he is well experienced. He can learn from that past experiences. So he could make the thing in a much perfected way. But what if the contractor is a beginner? There may be, for sure, there may be some imperfections on the building. So that's the thing with the physical appearance. Now, considering the software engineering field, it doesn't have a physical appearance, so there is more chance for becoming imperfections in the overall product. So past experiences have its own role, an important role in the software engineering field. And the next factor is the good quality programs. Good quality programs means we should make use of a good programming language, and the program quality should be effective. That means it should have a good user interface. It should be user friendly. The customer need not be a computer professional or a software professional. So the customers are making use of the software for his real life applications. So he should learn to use the software with ease. He should not struggle with that application. He should learn the usage of that software with ease. So it should be user friendly. It could be used for by common customers. So the application developed software should be user friendly. It should have a good user interface, and it should run on almost all available common platforms. So it should be compatible with all platforms available, common platforms available, and it need not make use of very expensive hardwares. He could use the software with ease in common available platforms. And another thing a customer expects from a software developer is that the developed project, the software development or engineering, should be cost effective. It should not exceed the budget level. So the expected budget, it should meet for the expected budget level. It should be always cost effective. So these are all the factors involved in the software engineering field. So as we said, software engineering is a systematic collection of good program development practices and techniques. The factors involved in the software engineering process are innovations, past experiences, good quality programs, and also cost effectiveness. Okay, so all these collection of technology, innovations, past experiences, cost effective planning, and good quality programs makes a good software engineering process. As we said, software engineering always makes use of past experiences. Yet software engineering is neither considered as a science or art. Why should the software engineering not be considered as a science or art? We said the engineering techniques includes systematic development, cost-effective techniques, past experiences, quantitative principles, alternative solutions. So it uses a principle. There is a difference. Why should we not consider software engineering as a science or art? Because it uses a quantitative principles for its developmental phases. The software make heavy use of past experiences, but the past experiences are used in a systematically arranged manner. Every science or art form makes use of the past experiences, but in a different manner. In an art form, they are merely using the past experiences, but in software engineering field, it makes use of the past experiences in a systematically arranged manner, and we provide theoretical basis for them. We are not merely using the past experiences, we are providing a theoretical basis for the same. We have a quantitative principle there. We have quantitative principles and we are giving a theoretical basis for the same. So there is a difference in using past experiences roughly and making use of the past experiences with a theoretical basis or providing quantitative principle for the past experiences, or making use of quantitative principles for the design process and developmental process. Also in software engineering or in programming field, different developers can derive different alternative solutions for a single program. So it is not necessary that a single problem should have a single solution. There may be alternative solutions. We have to optimize alternative solutions for a single problem, and the better option will be selected. So in many other field, science, art or mathematical fields, there may be a single solution for a single problem, but considering the software engineering techniques, for a single problem we can optimize different solutions, and different solutions, alternative solutions, should be optimized for a single problem and the best one should be chosen. So proposing alternative solutions for a single problem, that makes it different from an art form or a science form. Also, in engineering discipline, an approach for cost effectiveness is adopted. That is, we have to address the economic concern and the practical issues. For any other field, for example, for art forms, we are not concerned about the economic concerns or any other practical issues. But for software engineering, it should concern more with the practical issues. It should be cost effective always. It is a major concern. And engineering disciplines are based on quantitative principles, as said earlier, while on the other hand, science is based on the subjective judgments, or any art form is merely it is depends on it is based on the subjective judgments. But engineering techniques are based on certain quantitative principles, not subjective judgments. So all these things make software engineering different from any science or art forms. That means software development is considered as an engineering process, not as an art form. Even though it makes use of software engineering makes use of past experiences, and it has a lot similarity with any art form, but the development of a software is considered as an engineering because it have a pure theoretical basis, a strong theoretical basis, a strong quantitative principles. It is developed based on strong quantitative principles, and we are concerned with more practical issues. The practical issues other than the factors that we said here. So software, as we said, it have been used for more than 60 to 70 years. The early method of programming in just makes use of a built and fix programming style. What is this built and fix programming style? They quickly build a program, and the quality of the program will be very low when it is built quickly, without any planning or without any designing. It makes a poor quality program without making any specification, plan or design. So early method of programming, that is the build and fix programming methods, just on that, but they just quickly build and fix the program, and after testing the program they noticed several imperfections. So the imperfections on the developed product is the reason for the imperfections may be the lack of planning and designing in the starting stage. So the problem was the lack of well understood principles and systematic organization of past experiences. The pattern of evolution of technology difference. It is differ from the early period of development to the later period of development. So as it is said in figure, an art form makes use of the past experiences in an esoteric manner. That means it is merely making use of the past experiences. There is no systematic or there is no organized manner of using the past experiences. Rather than an art form, the craft users makes use of the past experiences, and here also it is making use of the past experiences in an unorganized manner. Roughly, an art form or craft form makes use of the past experiences in a rough manner. But for the engineering process, systematic use of past experiences and formulation of scientific basis, they make use of past experiences with a scientific basis. As we said earlier, there is a theoretical basis and a scientific basis. We make use of quantitative principles for the software engineering field. So it is different from an art form and a craft form. Engineering field The software engineering field makes use of the systematic past use of the past experiences and formulation of scientific basis, and it arrives at alternative solutions. Alternative solutions could be optimized for a single problem so that we could choose a better one, and it is cost effective, as I said earlier. So there is a vast difference from an engineering and craft or art form. So what is a solution for the overall software crisis? The software crisis is based on the expense of the customers. The expense of the customers for getting a perfect software. For a long time, organizations spent much more on hardware. Uh, it is clear that early 1960s, in early 1960s, there was a peak in hardware expenses. But gradually it lessens down and its software expenses become greater than that of the hardware. It's clear that nowadays customers are actually spending much more on buying software than on buying hardware. So the difference in this, that means the expense of the expense for getting a good quality software is a real crisis of the software engineering field. So I think you got an introduction or you got an idea about software engineering. We shall continue in the next class. Okay, thank you.